Talk about the day that won't die. We are still rocking day 4 here. We have the rare part 3, something that I couldn't get to in either class because this day is the longest day of the chapter. It is the day that will not end. And so on part 3, right now we're on page 5. We're going to be doing page 5 and page 6 will be these two here. So if you're wondering where we are, we're on day 4, page 5. And guys, the last part here is going to be maybe the toughest because we see that we're going to have to be dealing with what looks like an entire proof where we're not given statements or reasons. We have to come up with some of that. But really, if you use what you're given, it's not going to be too bad. So check it out. We're given that these lines are parallel. Okay, so we're not going to need converse theorems. Immediately I'm thinking, okay, if I see that, I'm not going to need any converse theorems. So that's a good sign. That is a very, 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 very good sign. Now, something else. We're told what this is and we're told what this is. And as soon as I see some algebra, as soon as I see algebra for angles, what do you guys think I'm thinking? Besides that, I'd like a cheeseburger. I'm thinking substitution is going to be coming into play. Substitution for sure is going to be coming into play if we're getting algebra for angles here. And here's angle 4. Here's angle 15 there. 4 and 15. Ah, and what are you guys noticing here? I'm seeing some alternate exterior angles. So we can already tell, okay, alternate exterior angles. I'm going to be substituting in these at some point, and I need to prove that this angle equals that angle. Okay. So let's start with what they give us. So statement 1, see if I can keep this all in picture. We know C is parallel to D. These two lines are parallel. We know that angle 4 is going to be equal to 2x plus 5. And we know angle 15 is going to be equal to 4x minus 7. And again, the reason for that is because they gave it to us. That's given. So let's start using what we can tell about this graph. We just said earlier, 4 and 15, aren't those? Yeah, those are alternate exterior angles. We can't really do anything with this information yet. Not yet, but we can do something with this. So step 2, we can say angle 4 and angle 15 are alternate exterior angles. And what's going to let us say that? You guys know it. That's straight definition of alternate exterior angles. So we got that straight locked up. But again, you guys know what's going to immediately follow that. We know that if we have a definition, we can do something with the fact that these are alternate exterior angles. If they are, that means these are going to be, well, they're going to be congruent. So how can we know that? Well, definition's not going to tell us that. That's going to be based off the alternate exterior angle theorem. Bada boom. Okay. Now here's where we get to switch things up a little bit. So because we know that angle 4 is equal to angle 15, I want you guys to think about it. This alternate exterior angle part's run its course. So where do we go next? Wait a minute. 4 and 15. What did they give us about 4 and 15? Oh, 4 equals that. 15 equals that. This is where that algebra is going to come into play. What can we do? We know angle 4 is really 2x plus 5. We know angle 15 is really 4x minus 7. And we did that using some good old-fashioned substitution. And from here, guys, we know that once you've substituted, this is where the math portion of the proof takes over from here. It's all about the math portion. So let's start solving for x here. So I'm thinking we could It's up to you guys. I'm thinking let's maybe subtract that 2x over. So if we subtract that 2x over, I've got 5 equals, subtract 2x, that'd be 2x minus 7. And again, we did that by subtracting. Then I'm thinking, well, if we have 2x over here, we probably need to get that negative 7 over, right? So let's add that 7 over to get 12 equals 2x. And then finally, we know we're going to divide to get x equals 6. Well, what good does that do? So we know we've got x equals 6. Well, couldn't you always plug 6 back in to both of these? Plug 6 back in. 2 times 6 is 12, plus 5 is 17. Angle 15, plug 6 in. 4 times 6 is 24, minus 7. That's 17. So you plug that back in, you get 17 for both. What lets us plug that back in? Well, that's substitution. And so using substitution, we can say that angle 4 is going to be equal to angle 17, which is what we were trying to say from the beginning. By plugging 6 back in, we know that those are equal. Woo! That's a big one. Talk about a nice proof there, man. That was a nice, detailed, kind of a little bit of switch-up proof. So last part of part 3 of day 4, we'll go to page 6. And hey, we like to see some of this right here, right? We got a few things that are going to help us out, but not many. But once again, let's use what they've given us here. Let's look at what they have given us. Take a second, guys. You can pause the video. What have they given us? Well, we got words. I see sup. What kind of angles often are supplementary? What kind of relationship? Well, 2 and 3, check it out. I see same side interior angles with 2 and 3. What else do you guys see? I see angle 1 and 4. Now, angle 1 and 4, these are same side exterior. That's not a thing. This is not a thing here. But we do know that 1 and 4 are going to be supplementary. So they're not going to be equal, but they're not going to be equal, but they are going to be supplementary. And what are we trying to prove? Oh, shoot. Parallel. If you're trying to prove parallel lines, we know that means converse theorem. We're going to have to, if we're trying to prove parallel, we know that's going to be the converse theorem, and you guys thinking that's probably going to be the converse theorem of same side interior. So we already know the ending. Check that out, guys. We haven't even started this problem yet, and we already know how it's going to end. Converse theorem of same side interior. I promise you. So we got this. Let's go. So 1 and 4 are sup. Okay. Well, before we touch that, let's look at 1 and 2. 1 and 2. Now, wait a minute. Aren't these vertical? Yeah, we got some vertical angles. Speaking of vertical angles, look at 3 and 4. Oh, shoot. Those are vertical angles too. And what lets us say that things are vertical angles? Well, that's based off the definition of vertical angles. And you guys know, we know what comes next. From this, it's always going to be, well, what does that mean if they're vertical angles? Angle 1 equals angle 2. Angle 3 equals angle 4. And that's going to be based off of what follows after the def. We got the vertical angle theorem. I'm getting pretty good at writing these pretty quick. It's actually not looking half messy either. That's not too bad. So guys, we've run our course. We've talked about these being vertical angles. We've talked about them being equal. We're going to have to go back to what they gave us now. What did they give us originally? Well, we know 1 and 4 are supplementary. So if they are supplementary, what does that mean? Oh, Well, that's going to mean angle 1 plus angle 4 is going to be 180. And we had these words that ended up leading to that math. So we're good with words, the math. What tells us something adds two angles add up to 180? That's a straight definition of sup. Okay. So we've kind of established that. But now wait a minute. What were we told here? Angle 1 plus angle 4 is 180. What do we know about angle 1 and angle 4? Doesn't angle 1 really equal angle 2? And how about angle 4? Doesn't angle 4 really equal angle 3? Oh. So couldn't we plug these in to say, okay, if angle 1 is really angle 2, then angle 2 plus angle 3 would be 180. And what lets us replace those? Well, that's good old substitution. Some good old substitution there. And so what can we say now? Well, 2 plus 3, if 2 plus 3 is 180, wouldn't that mean these are supplementary? Oh, shoot. But what helped us get that? We had math to words. This 180, this adding up to 180 ended up leading to our statement. So if it's math to words instead of words to math, this isn't going to be the definition, it's going to be the converse definition. Let's go, guys, let's go. Math to words means we got the converse definition. And then let's bring it back here. We know how this ends, guys. We know how this ends. If they're supplementary, remember what we said earlier? What's that going to mean then? 2 and 3 are, well, those are same side interior angles. And if they're same side interior angles, if we can make that statement, that's based off the definition of same side interior angles. And take it home, guys. If we know these are same side interior angles, that's going to lead right into us being able to say these lines are parallel. Because that's going to be adding up to 180. So these lines have that 90-degree factor. And so, if we're dealing with same side interior, we know it's going to be the converse. Remember, converse theorem? We got the converse, same side, interior, angle theorem. And so guys, that is day 4. We finally knocked it out. So remember, coming up next on this same day, we're going to be taking a look at day 5, and then we got our quiz. So I'll see you soon.